Hello everyone, in this part of my presentation, I will explain the concept and principle of pre-stressing used in pre-stressed concrete. In simple words, how we apply a force in advance to make the concrete stronger and more efficient under the load. As we know, concrete is very strong in compression but weak in tension. In a normal reinforced concrete beam, when an external load is applied, the bottom part of the beam experiences tension, which can cause cracks. As we know, concrete is very strong in compression but weak in tension. Prestressing means introducing a compressive force into the concrete before it experiences any external load. The idea is to pre-compress the concrete so that when external loads produce tensile stresses, they are counteracted by this initial compression. In other words, the concrete stays mostly in compression even under service loads, preventing cracks and improving performance. This is achieved by stretching high-strength steel tendons or cables and then anchoring them to the concrete.
For task 2, I will explain the pre-stressed concrete construction work with the help of a video. The video is from the YouTube channel called Practical Engineering with title What is Pre-stressed Concrete? In this video, we can see how pre-stressing is done and helps to prevent cracks and increase the strength. Let's watch a short part of the video first.
One solution to this problem of deflection in concrete members is pre-stressing, or putting compressive stress into the structural member before it gets put into service. This is normally accomplished by tensioning the reinforcement within the concrete. This gives a member a compressive stress that will balance the tensile stress imposed in the member once it's put into service.
As you guys can see, the video is really easy to understand. And moving forward, the main steps in producing pre-stressed concrete that we can see from the video are: first, steel tendons are placed inside the mold, and then second, the tendons are screwed with nut to put stress on the tendons, which is why they are called pre-stressed concrete. And third, the concrete is poured into the mold and we left it to harden. Finally, after the concrete becomes strong, the steel is released. When that happens, the steel pulls on the concrete, which creates a compression inside it. This compression helps the beam or slab resist the bending and cracking when it carries a very heavy load. In conclusion, pre-stressed concrete is an efficient and durable method that helps engineers to create safer and longer-lasting structures. Watching this video helps me understand the actual procedure and the importance of pre-stressing in modern construction. I would likely suggest you guys to watch the full video from the link here to gain better understanding. Thank you.
For task 3, I will be discussing a comparison between pre-stressed concrete and the conventional in-situ construction method. Both techniques are commonly used in the construction industry, but they differ greatly in terms of construction speed, quality control, and overall structural performance. Pre-stressed concrete is an advanced method that uses high-strength steel tendons which are tensioned before the concrete carries any load, and this pre-compression makes the concrete stronger and allow it to resist higher loads with minimal cracking or deflection. Pre-stressed elements are usually prepressed in a controlled factory environment where curing and material quality can be closely monitored. And once complete, these components are transported to the site and installed, making the overall construction process much faster and more efficient. And because of this, pre-stressed concrete provide a better precision, higher quality, and improved durability compared to traditional method. And one of the key benefits of pre-stressed concrete is the speed of installation. Since the components are already prepared, the on-site work mainly involves assembling and connecting the units. This minimizes the delays caused by weather or curing times and helps maintain a consistent construction quality. Pre-stressed concrete also minimize cracking, reduce maintenance needs, and extend the structure's lifespan, making it ideal for large projects such as bridges, high-rise buildings, and industrial facilities. And on the other hand, the conventional in situ method involves casting concrete directly on site. This process takes longer because it requires formwork, reinforcement, placement, pouring, and curing, and all of which depends heavily on weather and workmanship. Any variation during this stage can lead to consistencies in strength and durability. Although it is slower, the in situ method still offers flexibility for smaller or more complex structures that cannot use precast components. In summary, prestressed concrete is preferred because it offers faster construction, higher accuracy, and longer service life, while the conventional in situ method remains suitable for projects that require customization and flexibility.
The prestressed concrete construction contribute to SDG 9 and SDG 11. As for SDG 9, it builds strong and durable infrastructure like bridges and buildings. Uses less material but gives higher strength. Then, it encourages innovation through modern construction and methods. Then, precast prestressed parts made in factories improve quality and speed. The facts to support this statement for SDG 9 is it uses 20 to 30% less material than normal reinforced concrete. Then, the construction time can be reduced by up to 50%. As for SDG 11, it creates safe and long-lasting structures for cities. Faster installation reduces traffic and noise on site. It helps build affordable housing using precast systems. Then, it improves urban transport with durable bridges and flyovers. The facts to support this, which is the SDG 11, it needs less repair due to reduced cracking and corrosion. The precast housing can cut waste by up to 60%.